Welcome to Deep Tech Dharma, an autonomy thesis. So, India can put a nuclear submarine in the ocean.
Oh, absolutely. And a rocket on the moon.
Right, but if you look out the window at any commercial airport, like in Mumbai or Delhi, every single passenger plane you see is imported.
Yeah, it's a strangely uncomfortable paradox, honestly.
It really is. You've got this nation with, absolute cutting-edge sovereign capability in space exploration and naval defense, but for a whole century, India has never mass-produced its own civilian passenger aircraft.
Never. It's a striking historical gap. I mean, the entire domestic aviation sector has essentially functioned as this massive consumer of foreign engineering.
Right, just writing checks to other countries.
Exactly. You're buying from Seattle or Toulouse, but you were never actually building the core technology at home.
And it isn't like the country doesn't desperately need revolutionary transport, right? I mean, for everyone listening, I want you to picture the daily scene in Bengaluru.
Oh, boy. The traffic.
The traffic. You are sitting in grueling, hours-long gridlock. It's that bumper-to-bumper reality where you can literally watch your life ticking away on the dashboard clock.
Yeah, you're just trapped.
Totally trapped. So today's deep dive is zeroing in on a stack of sources that detail a massive bet on the future of urban mobility. We're looking at a startup called Sarla Aviation.
Which is a fascinating company.
It really is, and their mission is staggering. They want to put Indian-made electric flying taxis over Indian cities by the end of this decade, so by 2028.
Which, I mean, that is an incredibly audacious goal.
Right.
Especially given that whole 100-year historical deficit we just talked about.
Right, and, reading through our sources, my first thought was immediately about leapfrogging.
Oh, like with telecoms.
Exactly. We've seen this play out before. India essentially skipped the expensive decades-long process of laying copper landline telephone wires across every single village and just jumped straight into mobile phones and cheap data.
Yeah, they bypassed a whole technological era.
Right. But I have to wonder, can a country that completely missed out on the traditional era of building combustion engine airplanes, like leapfrog straight into the sci-fi realm of flying electric taxis?
Well, that is the exact thesis Sarla Aviation is betting its survival on.
Mm-hmm.
And to understand how that leapfrog is even physically possible, we have to look at the technology itself.
Okay, let's unpack that.
Because it's driving what industry insiders call a century reset. The technology is EV2. That stands for electric vertical takeoff and landing.
Got it.
And because this is a completely new propulsion method, nobody actually has a 100-year head start. The playing field has essentially been leveled back to zero.
Let's unpack the mechanics of that real quick, because when you say vertical takeoff, we aren't talking about a plane that needs a 2-mile concrete runway.
Not at all. And EV2 lifts off straight up into the air, exactly like a helicopter.
Yeah.
But that is where the similarities end.
Okay, how so?
Well, helicopters are incredibly inefficient machines. When a helicopter is hovering or even moving forward, it's essentially brute forcing its way against gravity.
Oh, right, just pushing air down constantly.
Exactly. It has to take a massive column of air and slam it downward just to keep a multi-ton vehicle suspended. That requires a phenomenal, continuous burn of energy.
Which is why they're so loud.
Right. Notoriously loud, super fuel thirsty, and incredibly expensive to maintain.
So an eVTOL bypasses that brute force problem.
It does. Through a maneuver called a transition flight. Once the eVTOL uses its rotors to lift vertically to a certain altitude, it actually tilts those rotors forward, or uses a secondary set of propellers, and begins flying on fixed wings, just like a standard airplane.
Oh, wow. So it shifts mid-air.
Exactly. And once you are gliding on wings, aerodynamic lift takes over. You're no longer fighting gravity, you're surfing the air currents. This wing-borne cruise phase makes the vehicle exponentially more energy efficient than a traditional helicopter.
Okay, so think of a transition flight like a swimmer doing the butterfly stroke.
Oh, that's a good analogy.
Right. Pulling your entire body up and out of the water vertically requires these massive, exhausting bursts of energy. But the moment you level out and glide forward, momentum takes over and the energy expenditure just drops dramatically.
That's exactly it. That moment of leveling out is the magic of this technology.
But the global race to perfect that butterfly stroke is already sprinting ahead, isn't it?
So,
According to our sources, China's EHang already has a certified passenger Eve 2.
Yeah, they're moving incredibly fast.
And over in the US, companies like Joby and Archer are leading the pack with huge capital. And what's interesting is the path to simply import this tech into India is already paved.
Right, the IndiGlobe deal.
Yeah, IndiGlobe, which is the parent company of India's largest airline, Indigo, they've already partnered with America's Archer Aviation to bring foreign air taxis into the country.
Which really sets up a fascinating tension. India faces a huge choice right now. It can either sit back and import the next generation of flight, remaining a consumer just like it did with commercial jets.
Or it can attempt to build the ecosystem domestically.
Exactly.
But look, I have to push back on the core premise of these vehicles for a second. Whenever I hear the phrase flying taxis, my brain immediately goes to luxury.
Sure, yeah. VIP transport.
Right. If you are stuck in that Bengaluru gridlock lookup, aren't these just going to be a shiny new toy for billionaires to hop from their penthouses to the airport while you and everyone else are still breathing exhaust fumes down below?
It is a very common initial reaction. I hear it all the time. But it misses the fundamental economics of the third dimension.
The third dimension.
Yeah, low-altitude airspace. It is arguably the only untapped infrastructure left for congested megacities. I mean, you cannot infinitely widen roads in a city like Mumbai or Bengaluru.
True, there's just no physical space.
And digging underground for subways, it's astronomically expensive, highly disruptive, and takes decades per line. But the air above the city is essentially a blank canvas.
Okay, but how does that make it not just for billionaires?
Because if you can scale the manufacturing of these electric vehicles to the point where the unit economics makes sense, you aren't building a luxury helicopter service. You're building mass transit.
Which brings us to the Indian challengers stepping up to the plate. Let's meet Sarla Aviation.
Yeah, let's dive into them.
So the company was founded very recently in Bengaluru, October 2023, by a remarkably young team, Adrian Schmidt, Rakesh Gaunkar, and Shivan Chauhan. And they brought significant engineering experience from leading global eVTOL companies back to India.
And the name itself carries a lot of weight, too.
Oh, absolutely. They named the company after Sarla Aviation, who was the first Indian woman to ever earn a pilot's license.
It's a very deliberate signal. They're
Yeah.
trying to reclaim a piece of Indian aviation history while literally building its future.
And their flagship aircraft carries that exact same symbolic weight. It's called Shunya, which means zero in Sanskrit.
Right. A clever nod to the zero emissions aspect of the vehicle.
Yeah, and it also honors the mathematical concept of zero, which is arguably India's most famous historical export to the world. They unveiled this publicly in January 2025. But let's look at the Shunya aircraft itself, because this is where Sarla's design choices diverge wildly from their Western competitors.
Wildly. It's a completely different approach.
Right, so Joby and Archer, big American companies, they're designing their air taxis to carry 4 passengers. But Sarla purposefully designed Shunya to carry 6 passengers plus 1 pilot and a 680-kilogram cargo payload.
That capacity choice is really the defining gamble of their entire business model. Choosing a 6-passenger cabin over a 4-passenger cabin isn't just some arbitrary design preference.
No.
No, it's a direct, highly calculated response to Indian market economics. Their stated goal is to turn a 90-minute road commute into a 10-minute flight, but, and this is the kicker, to price it similarly to a premium ride-hailing service.
Think something like an Uber Black.
Exactly. Uber Black pricing.
And to hit that price point, you need volume. It's like the difference between designing a 3-row electric SUV for a family road trip versus a 2-seater sports car. The SUV makes way more financial sense for moving people economically because you are splitting the journey's cost across more wallets.
Precisely. To achieve a ride-hailing price point in India, you have to distribute those fixed costs. So the pilot's salary, the battery depreciation, the charging infrastructure across more paying customers per trip.
More seats per flight equals a lower fare per seat.
Exactly.
Okay, I understand the spreadsheet logic there, but let's talk about the physics.
Oh, the physics are punishing.
Right, because my instinct is that adding 2 extra passengers plus their luggage completely warps the aerodynamics. I mean, the physics of vertical lift are brutal on battery cells.
They really are.
If hovering is already the most energy-intensive thing an aircraft can do, aren't they biting off way more than they can chew with the current state of battery density?
You've hit on the core technical risk of the whole project. The power-to-weight ratio is the ultimate bottleneck in electric aviation. Batteries are extremely heavy, and unlike jet fuel, a battery doesn't get lighter as you burn energy.
Yeah, that's such a wild concept.
It is. You have to carry the exact same dead weight when you land as when you took off. So adding 2 extra human beings means You need significantly more thrust to pull that vehicle out of the hover and into a forward glide.
Which is an enormous technical hurdle.
Huge. And this leads us directly into the massive challenges highlighted in our source stack, because it's important to state clearly, the full-scale six-passenger Shunya hasn't actually flown yet.
Right. They only began ground testing a subscale demonstrator recently in December 2025.
Yeah, just a scaled-down version.
So imagine you were sitting in that Shunya cabin. The rotors tilt forward for that transition flight we talked about, the butterfly stroke. You might expect the roar of a jet engine, but because it's electric, you just hear the hum of the rotors.
Which sounds lovely, but
But that exact moment of transition where the aircraft stops hovering and starts flying on its wings is the single most complex aerodynamic maneuver an eVTOL performs.
it's incredibly difficult to get right.
The software has to perfectly balance the loss of vertical thrust with the gain of aerodynamic lift, and Sarla still has to prove they can do it at full scale with a heavy, multi-ton payload.
And honestly, if we look at the financial realities, physics isn't even their biggest obstacle right now.
No.
No, it's the capital chasm. Building advanced aerospace hardware burns through cash at an astonishing rate.
Yeah.
Sarla has raised about $13.4 million across 5 rounds, including a $10 million Series A in January 2025.
Which sounds like a lot to a normal person.
But in aerospace, it's a fraction of what their competitors have secured. We are talking about millions of dollars versus the multi-billion-dollar war chests held by companies like Joby and Archer.
Look, waiting for others to make mistakes is a smart strategy if you are building like a food delivery app, but hardware is notoriously unforgiving.
Extremely unforgiving.
Right. If a software startup pushes a bad update, the app crashes and you just patch it overnight. If an aerospace company gets the transition flight wrong, the physical vehicle drops out of the sky.
Yeah, the stakes are literal life and death.
Plus, if Joby and Archer spend billions to patent the most efficient rotor tilt mechanisms, Sarla is legally locked out. So I have to ask, doesn't this whole frugal aerospace strategy just mean they are too poor to genuinely compete in a capital-intensive industry?
It is a very fair critique.
Yeah.
And the graveyard of electric aviation pioneers kind of proves your point about how unforgiving hardware can be. I mean, well-funded pioneers in Europe like Volocopter and Lilium, they raised hundreds of millions of dollars and still insolvent.
Oh, wow. Hundreds of millions and still fail.
Yes. However, the frugal engineering strategy that Sarla is using isn't about cutting corners on safety, nor is it necessarily about dodging patents. It is really about R&D efficiency. Well, the billion-dollar companies had to spend heavily to lobby Western regulators to create the very first certification frameworks from thin air. They had to pay a huge premium to battery suppliers just to force the early innovation cycles. Sarla, on the other hand, is stepping into an ecosystem where the baseline viability of eVTOLs is already proven.
Okay, I see the angle. It's like, would you rather be the very first person in history to invent, sew, and test a parachute, jumping off a cliff hoping the math works?
Right.
Or would you rather be the second person to jump after watching exactly which seems ripped on the first guy's parachute?
That's a great way to look at it. The second jumper doesn't have to spend years inventing the concept of drag. They just have to focus on stronger stitching. Sarla can leverage India's massive engineering cost advantage to adapt existing aerodynamic principles to the specific needs of the Indian market.
But you are right that $13 million won't get you to mass production. To survive that valley of death between a working prototype and a commercial fleet, Sarla really relies on a network of incredibly strategic partnerships.
Oh, their backing is heavyweight.
It is. Their investor list is basically a who's who of Indian consumer tech royalty. You've got Zeroda's Nikhil Kamath, Flipkart's Binny Bansal, Swiggy's Sriharsha Majuti.
Yeah, these are people who deeply understand the logistics of moving millions of physical things through chaotic Indian cities.
Exactly. But the most vital strategic backing came in 2026 when Indigo Ventures, which is the investment arm of India's largest airline, took a 10 crore equity stake in Sarla.
Which, frankly, is a masterclass in corporate hedging by Indigo.
Explain that, because we just established a few minutes ago that Indigo's parent company is actually importing American air taxis from Archer. So why fund the domestic rival?
Because importing hardware leaves you vulnerable. Indigo is securing a near-term path by importing Archer's vehicles, ensuring they aren't left behind when the market first opens up.
Right, they get in early.
But by taking a financial stake in Sarla, they're planting a seed for a homegrown alternative. If Sarla succeeds, Indigo gets early access to an aircraft designed specifically for their domestic market dynamics, likely at a much lower procurement cost.
It is a massive stamp of industry validation. All-man airline place a bet on them.
Absolutely massive.
They also brought on some serious regulatory firepower. In August 2025, they hired a former civil aviation secretary, Rajiv Bansal, as an advisor.
Crucial move.
And that is so crucial because the DGCA, India's aviation regulator, currently has no framework for certifying an eVTOL. What does that actually mean on the ground?
It means years of potential delays.
Right. It means Sarla has to prove safety standards that literally do not exist yet. You don't bring the former head of the aviation ministry on board unless you realize that engineering the plane is only half the battle. The other half is navigating India's notoriously complex bureaucracy to actually write the rulebook.
Navigating the regulations gives you permission to fly, sure. But manufacturing scale gives you an actual business. You cannot change urban mobility by hand-building 10 aircraft a year in a boutique workshop.
Which leads us to the Sky Factory. In November 2025, Sarla announced a massive 1,300 crore investment, and that's about $145 million, for a 500-acre manufacturing campus in Anantapur, Andhra Pradesh.
500 acres, that's a serious footprint.
Yeah, and their target is to eventually produce 1,000 aircraft a year by 2029, and crucially, they are taking steps to ensure they aren't just assembling imported parts like a giant Lego set.
Because right now, India currently imports the advanced battery cells necessary for these vehicles.
Right, so in January 2025, they partnered with Sona Speed to localize the manufacturing of the critical electric motors and electronics right there in India.
And this is where we see the classic industrial playbook in action. Think about how Maruti transformed the Indian automotive sector in the 1980s.
Oh, that's a perfect parallel.
Yeah. When Maruti set up shop, they didn't just build cars, they pulled an entire domestic auto components ecosystem up with them. Sarla is attempting to do the exact same thing, but for advanced electric aviation.
Why is localizing the supply chain so vital, though? Like, if a motor from Germany is already perfect, why spend the time learning to build it yourself?
Because if you import your electric motors from Europe and your advanced battery cells from abroad, your profit margin isn't really yours.
Oh, I see.
You are constantly at the mercy of global shipping rates, currency fluctuations, and geopolitical tariffs. To hit that affordable, uber-black price point for the everyday consumer, Sarla needs absolute control over their unit economics.
Building the supply chain locally is basically the only way to insulate themselves from global supply chain shocks.
Exactly.
And it seems they aren't the only ones who recognize how massive this opportunity is. There's a fierce domestic rivalry brewing here. Sarla is facing off against multiple homegrown companies.
It's getting crowded.
Yeah, you've got the E-Plane company, which was incubated at IIT Madras by Professor Satya Chakravarty. Then there's Blue Jay Aerospace and JetSetGo. It sounds like multiple Indian states and brilliant academic hubs are practically going to war over who gets to own the domestic skies.
But healthy competition is the ultimate proof of concept. The presence of multiple serious domestic players proves that the ecosystem is actually maturing. It isn't just one outlier startup making a wild bet anymore. It is the birth of an entire industrial sector.
But, you know, the exact same quiet, heavy-lift physics required to move 6 executives over Bengaluru traffic solves a much darker sovereign problem for India.
Yes, the dual-use applications.
Exactly. Our sources highlight a dual-use application for these vehicles that is arguably much more critical than the commercial taxi market. We're talking about medical and military logistics.
This is where the narrative shifts completely from urban convenience to critical and national infrastructure.
Right. In October 2025, Sarla partnered with Aram to develop a VTOL medevac aircraft. India has one of the world's lowest densities of air ambulances.
It's a huge issue.
Dispatching a traditional helicopter for an emergency is incredibly expensive, and they require specialized landing zones. But if you have an electric eVTOL that costs a fraction of the price to operate,
It fundamentally changes the math on emergency response.
Yeah.
Subtly, rapid medical evacuation isn't restricted to ultra-high net worth individuals or specialized military units.
it's accessible.
Exactly.
Yeah.
And speaking of the military, the defense applications are profound. Think back to the specifications of the Shunya aircraft. It is designed to lift a very heavy payload, 680 kilograms vertically.
And because it's electric, it doesn't have a combustion engine screaming at 100 decibels.
Exactly. A vehicle that can silently lift over half a ton of cargo vertically is a strategic game changer for a military planner. We're talking about border supply logistics, moving critical ammunition, and conducting casualty evacuations in rugged, high-altitude terrain without announcing your presence to the enemy from miles away.
Wow. I want you, listening, to imagine that. Imagine a silent electric ambulance landing on a narrow, treacherous mountain pass in the Himalayas where a traditional helicopter would just be too loud, too large, and too vulnerable.
It gives you chills.
It really does. When you look at that capability, you realize Sarla Aviation isn't just trying to build a taxi company, they're trying to build the physical operating system of the low-altitude sky.
That is a crucial insight.
Yeah.
Whoever successfully builds the first scalable fleet of these vehicles will naturally be the one who dictates the infrastructure.
Yeah, they set the standard.
Right. They will help design the vertiports, the physical landing pads on city roofs. They will help develop the low-altitude air traffic management software. And that very same infrastructure will eventually write the rules for automated drone delivery networks and security airspace for the next century.
It is the ultimate infrastructure play. You know, when we step back and look at the sheer audacity of Sarla Aviation, it is a perfect encapsulation of technological ambition. A century after Sarla Thakral became the first Indian woman to fly a plane, India is staring at a brand new starting line.
A reset, back to zero, back to shunya.
If they can successfully execute this massive sky factory, if they can hit that 1,000 aircraft a year manufacturing target and prove their localized engineering model works against the brutal physics of vertical lift, the paradigm flips entirely.
It really does.
India goes from being a perpetual importer of foreign passenger planes to a potential exporter of affordable, heavy-lift electric aircraft for the entire global south. They could be exporting this technology across Africa, South America, and Southeast Asia.
At that point, the technology transcends transport. It becomes a major instrument of economic diplomacy.
So to you listening right now, the next time you are sitting in a car, gridlocked in traffic, watching the brake lights stretch out for miles, I want you to look out your window. Look straight up.
Yeah, look up.
Because there is a massive, invisible infrastructure race happening in the blank space right above your roof. A race to claim the third dimension.
The sky is no longer just empty space. It is the final frontier of urban development.
And that leads to a really wild thought I want to leave you with today. Think about how this technology shifts the very concept of real estate.
Oh, this is a fascinating angle.
Right. For centuries, property value was dictated entirely by road access. The most valuable, expensive part of a commercial building was the ground floor, facing the busy street. But in a world where eVTOLs are ferrying thousands of people across the city in 10 minutes, what happens to the layout of a city?
It completely inverts the traditional model of urban planning.
It really does. Suddenly, the most valuable front door of a commercial skyscraper isn't on the ground floor anymore. It's on the roof, facing the sky.
The penthouse becomes the lobby.
Exactly. Yeah. Which begs a fascinating question. As this low-altitude airspace becomes the most valuable, highly trafficked commuting lane in the city, who really owns the air above your house? And when that invisible sky infrastructure finally becomes visible, are we going to see a clean, organized utopia above the clouds, or are we just exporting our gridlock straight into the sky?